We started off with, last class we have seen an expression we have seen. Okay. Okay. Yeah. So if we have found that if some boolean expression given which has been given, if it has not been given in the standard form, how to convert that into standard forms or canonical forms, which are SOP or POS. Next, we have seen that the SOP and POS implementation is having some kind of form. Okay, the form may be, if it is SOP, it is like all the AND gates, so followed by a OR gate, isn't it? And for POS, it is all OR gates followed by an AND gate. We have seen that the importance of NAND and NOR. What was the importance of NAND and NOR? Okay, we can use that gate for any purpose. Okay, that's why it's called the universal gate. What else? Why only NAND and NOR? Why not AND and OR as a universal gate? Yeah, so the advantage that we get is NAND and NOR usually can be implemented in fewer number of gates. Okay, and we may have uniform implementation or uniform fabrication. Like a logic can be implemented using only one gate, one type of gate. So that may be an advantage. So after that, we have seen some examples, right? We have taken an example of given a problem, how can we formulate that in a Boolean expression, and how can we realize it? Okay, we have seen the procedure for that. By if the Boolean expression has been given, we need to convert into standard form a truth table, then realize that circuit using POS or SOP form. Okay. Let's go ahead. So today is 20th. We'll see today something very, very important. So far we have seen that we have used many axioms, right? Say for example, you remember the last class, what we have seen was there was an expression given and I have asked you to reduce, we have defined a term literals. I have asked you to reduce that expression to fewer number of literals. Okay, what was the advantage? The advantage was we can realize the same Boolean expression with fewer number of literals, fewer number of devices, and hence small electronic devices will be required, small cost, and everything will be small. I mean, it's a nice compact realization was possible. So that we have used using Boolean expression, right? I have also given a few examples for you for the homework, and you might have find some difficulty. What property we have used for compacting any Boolean expression? We have used distributive property. We have used combination. We have used what? Combination property, right? The distributive property, like we have used, let's say there are three different variables A, B, C. We have used a property like this. So if the expression was given out to be something like this, A, B, or AC, we have simply reduced that to this one, isn't it? And BC, if the expression was something like this, we have reduced back to this, right? So we have used this combination properties. What else we have used? There was one more property which we have used, x plus x bar equals to x bar. We have used these properties also. Okay, there was one more property which we have used widely, was xy plus xy bar. That is nothing but x. This property number, I don't know what property number it is. If some expression it varies only with one variable, the other being constant, you can simply remove that variable. So we can simply take x common, y plus y bar equal to 1. So that's what is proved. So while compacting any Boolean expression, this was the procedure, right? And we may not get the procedure may be different for each of you. There is not a systematic way of reducing the number of literals, and sometimes it may happen that you may not get the reduced form so easy. Okay, That's why there is a systematic method which Karnoff has given. Okay. So let's see a systematic approach for Boolean expression reduction. This method, okay, or this approach is called as Karnoff approach. This was given by M. Karnoff in 1954. Karnoff's method, or it's also called as K-map method. The original paper was, so homework for you to find it out. This paper, a map method for synthesis of combinatorial logic circuits. Find this paper, you'll find some interesting stuff here. Alright. So what this method do is, okay, it makes, it's like a systematic approach. What this method does is, it uses all the axioms which we have seen, right? For reducing any Boolean expression, there are some properties which are required, the distributive property, combination properties. So this method utilizes those in systematic way, and we can get, guaranteed minimal form of any Boolean expression. Okay, so there is some procedure for that. So it all begins with forming a map of any Boolean expression. Okay, say for example an expression has been given. Okay, so let's say it is x comma y, and this is something like this, 1 2. Okay, so what does it indicate? It's m1 plus m2, or you tell me m1 is nothing but x bar y, and this 2 is nothing but x y. This is okay. Now whenever this Boolean expression has been given, or sum of min terms has been given, the first step is to form a map out of this. The map can be like this. Okay, draw map. Map means a kind of tabular form. Say first check how many variables are there. 2 variables, so it will be 2 variable K map. So draw something like this. So 2 variable, there are 4 possibilities, so there are 2 to the power n such boxes in this map. Okay, tables. So on the column side, by row wise, I will say x. It may be y also, and here I may write y. Okay, x or y or x, anything is fine. And I will define this, I label this squares as various possibilities of y, 0 and 1. X is having another possibility, 0 and 1. Okay, so if we go min term by min term, what it would be? This will be m0 xy, m1, m2 and m3, isn't it? So for which possibilities, for which combination it is 1? For only 1 and 2, right? This one. So mark those as ones. I'll draw it again. So here it should be 1. Y, x, 0, 1. I'll mark this as 1 and 1. Leave the rest. Okay. Leave the rest. Assume them to be 0. Okay. So this is what you need to do. For if suppose there are 2 variables, say for example there are 3 variables, it's f of x, y, z equals to sum of say 1, 2, 3, 5 7. That's it. Then what you can do is you can form again a k-map of how many variables are there? 3 variables. Okay, so 3 variables can be like 1 variable in the row and 2 in the column, or maybe 2 in the row and 1 in the column, something like that. So just draw it here. So you may draw this map something like this. So here I may take x, y, z, or I can make this map vertical, okay, and write y, z along the rows and x along the column. Okay, that also I can do. I mean, you can simply invert this map. Okay, it's up to you. Okay, so 0 1. What are the possibilities of y and z? 0 0 0 1 1 0 1 1. Okay, but while writing this possibilities, you just have to remember that while labeling these squares, you should label in such a way that they should differ in only one bit or one variable. Say for example 0 0 to 0 1. How many variable it has been changed? Only one variable. Here 2 variables have been changed. Okay, 0 has become 1 and 1 has become 0. Here 1 variable. So if we exchange this somehow, our job is done, right? So for example, I can do something like this. I'll rub this. I'll get 1 1 here and 1 0. Now the two consecutive cubes, okay, the squares, two consecutive squares differ by only one bit. Okay, 0 0 0 1 it differs by only one bit. 0 1 1 1 it differs by one bit. Again here it differs by one bit. So can you tell me which kind of code this is? Yes, in gray code, each consecutive number will differ by only one bit. Okay, so you need to follow the gray code fashion. So let me write that. So gray code fashion. Alright, now you can mark the terms here. 1 2 3 5 7. Okay, where is the 1? See here, 0 0 0 1 is here, 2 is here. Okay, 0, what is 2? 0 1 0, right? So x is x, y, okay, 0 1 0, so it is 2. Okay, then 3 5 7, where is 3? Here, 0 1 2 3, here it is. Okay, 3, then 5 7, 4 5 5 is here, 6 7. Got this? Anyone who didn't get this? Okay, I will just label this. Should I repeat? Okay, so what I'm saying is, first, whenever an expression has been given to you, okay, I'll just control Z. Whenever an expression has been given to you, the expression has been given this one, right? First, find the number of variables it has. There are 3 variables. So let's make a map of 2 to the power n squares. Okay, map of 2 to the power n squares. How many variables are there? 3 variables. So that becomes 8 squares. So 8 squares we can draw something like this. We can draw the vertical fashion also. Okay, that will also become 8 squares. Any way is fine. Okay, and label those okay, along the rows and columns as different variables, and see what all the possibilities would be there for those variables. Say for example x is only one variable, only 2 possibilities, 0 and 1. For yz there are 4 possibilities, 0 0 0 1 1 0 1 1. But you should label in such a fashion that 2 consecutive squares must differ by only one bit. Okay, only one bit. That is like a gray fashion. Okay, in gray 2 consecutive numbers differ by only one bit. Okay, why that is so, I'll explain that. Okay, so once you have completed this, okay, just label them. Okay, this is M0, M1, this is M2 here, M3, isn't it? So 4, 5, 6 will be here, M7. Is that okay? I'm simply labeling it time being. Okay, if you if you practice a lot, okay, you don't need to label this. So you put ones wherever these literals are present. This min terms are there. 1, 2, 3, 5, 7. So 1, 2, 3, 5 is here, and 7. That's it. You leave the rest. Assume them to be 0. Is that okay? Okay. Now, why we are making so? Okay, why we differ by only one bit? Just because we will be able to use this property xy plus xy bar. The two consecutive numbers. Okay, this is 0, this is 1 1, and this is 1 0. They differ by only one bit. So we can reduce them. Okay, we can make use of. We can combine this the adjacent ones to form only one variable. Okay, that's why we label in such a fashion that they should differ by only one bit. Okay. Now, same thing you do for 4 variables. Can you do that quickly? So let the f be equals to, do that. Yes, please. Let it be A, B, C, D. If I'm writing this, okay, for 4 variables, similar procedure is opted. Okay, you make, now how many variables are there? 4. So 2 to the power 4, that means 16 squares will be required. So let's make 16 squares. Yes, anyone can ask, no problem. Yes, please. No. I'm giving you an expression. I'm just specifying. See, there is some circuit which we want. Okay, this is my specification. I want the circuit to act such that it will be 1 only for this combination. Okay, this I have given you as a specification. Okay, once I have give those specification, how the variables would be, how this would be boiled down to expression. Can you tell me the expression quickly? 1 ABCD, na? ABCD, ba. This will be 1. Or tell me for 2. ABCD, it will be, or tell me ABCD, how many? 5, na? 0 1 0 1. Tell me for 7. Tell me for 9. So 8 is here, 9, and so on, right? So A, B, C, D. So 11 would be okay, and what else? Plus A, B, C, D. What is this one? 13. That's it. A, B, C, D. What about 14? Okay. So how many literals are there? See, yeah, I mean 4 literals. How many expression terms are there? 1, 2, 3, 4, 5, 6, 7, 8 terms. 8 terms. Okay. Each of them are having 4 literals, right? So, I mean, we'll require how many gates here? Let's calculate the cost. Let's calculate the cost. How much cost is required? How many gates are here? 4, I mean, this is 4 input AND gates will be required, right? So, how many such? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 4, right? 8 into 4 are the inputs. Okay. How many gates are there? Plus 8. And how many OR gates are there? Oh, 1 nahi. 1, 2, 3, 7 gates, right? 7 OR gates, 8 AND gates, and these are the number of inputs, right? Inputs. What is the cost? 40? 47? This is the total cost. Okay. Now, as I said, these Boolean expressions can be reduced using various axioms of Boolean algebra. But what I said was, those axioms may be too tedious to go for. okay, because we may not know where to start from. It may not be guaranteed, it may not be so obvious that this expression could be reduced or not, okay. Sometimes it may not be easy enough to get that smaller expression. Like we have seen that I have asked you to reduce it back to 3 literals. We may not know till what literals it can be reduced, a given expression. So what K-map does is, Karnaugh has given a method, a map method, wherein you can can find a guaranteed reduced form expression of any Boolean expression. You can get a reduced form equation for any Boolean expression. Okay, so that's what the method I am finding. So without applying any kind of optimization, okay, I am getting a cost around 47. Let's do, okay, this K-map, what it will do is it will definitely find a method, okay, devise a method. It's a utility, okay, from using which we can reduce this cost to minimum as possible. Okay, so first step of the K-map is to form a table with having the number of squares as good as equal to 2 to the power number of variables, those are 4s. Now you form 16 squares. Form 16 squares. I'm forming 16 squares. Once you form 16 squares, label them with respect to these variables A, B, C, D. I may put A, B here, C, D there, doesn't matter. Okay. Label in such a way. Now label the possibilities of this, okay, C, D. What are those possibilities? 0, 0, 0, 1, 1, 0, 1, 1. But you should label in such a way that two consecutive squares should differ by only 1 bit. So it is 0, 0, 0, 1, 1, 1, 1, 0. Okay, in a gray code fashion. In gray code, what it says? Two consecutive squares differ by only 1 bit. Similar thing here, 0, 0, 0, 1, 1, 1, 1, 0. Now you can label it. Say for example, what is this square? Can you tell me what is this square? Can you find the expression for this? This A bar, okay, A bar, B, C bar, D. So that's the expression which is actually labeled by this box. That means what? Each and every square, okay, each and every min term is having its place in this K-map. Each and every min term and max term is having its place in this K-map. Okay, so 1, 2, 3, any number of it is having how many possibilities? 2 to the power 4 possibilities. That means 16 such possibilities. For each and every min term there is a special place in this K-map. Okay, now we have given the expression such that, okay, here 1, 2, 5, 7, 9, only these terms should be true. That is what our specifications are there. So make only those as ones. Okay, tell me 1, 0, 1, no? 2 should be here, 0, 1, 2, 3, something like that. Yeah. Then 5, 4, 5, 6, 7, 9, 8, 9, 10, 11. Then 13 and 14, 12, 13, 14. Anyone who didn't get this? Anyone who didn't get this? Is it okay? So if you are, if you want to begin with, you can simply put this M0, M1, M2 and M3. You continue in this fashion, M4, M5, M6, M7, M8 is here, isn't it? You can verify 1, 0, 0, 0, that is 8. M8, M9, M10, M11. Now you can M12, 13, 14 is here, and 15. Okay, it's one only for 1, 2, 5, 7, 9, 11, 13, 14. Is this okay? Is this okay? Fine. So that's the first step. Now, okay, so let me go to the next page. Alright, so what we have done, we have found how many number of variables are there. We have formed a squares, okay, equal to the power n number of squares we have formed. We have kept one only in those variables, okay, those squares where the min terms are true. Okay, if it had been max term, we would have labeled as zeros. Okay, we have made sure that the labels are such that it should differ by only 1 bit. Okay, that's very important. Now, next step is to find, so Let me write that. Okay, let me write the steps first. Find adjacent. Find adjacent ones. Find adjacent ones. Now see the definition of adjacent. Okay, I'll clarify it here. Say for example, it's a two variable K map. Example. Okay, best thing is to give an example and then say for example, it's a two variable K map. That means 4 squares. So it's A and B, two possibilities 0, 1, and here also 0, 1. Okay. Now consider this example. Okay. Okay. Well, before that, I'll simply label this M0, 1, 2, 3. Okay. Each minterm, okay, each square is said to be an adjacent to another only if it differs by, it depends. I mean, adjacent means what? Adjacent by what amount? Say for example, you are making a group or adjacent by only, let's say for example, you are saying that M0 and M1 are adjacent. That means you are making a group of 2. Okay, if you are making group of 2, it should differ by only one variable. If that is so, it is said to be an adjacent. Okay, see here, they differ by only B variable, A remains the same. So that's why they are said to be adjacent. How many other, what would be the other possibility? I can make this as adjacent. M0, see, they differ by A, but B remains the same. If you are grouping, making a group of 2, they should differ by only one variable. Okay, can I make group of this? See here, no. M0 is A 0 0. Okay, A is also 0, B is also 0. Here A is 1, B is also 1. Okay, they differ by 2 variables. We can't apply those combination property. Okay, that's why we should not consider that as an adjacent. Okay, is it clear? You should consider the adjacent squares. Okay, only if you are making a group of 2. Okay, they are said to be differ by only one variable. They should differ by only one variable. Say for example, you are taking a 3 variable K map. Let's say ABC 0 0 0 1. Let me label it 0 1 4 5 6 7. Now see here, if you need to find a group of 2, isn't it? Just pay attention here. If you need to find a group of 2, okay, if you want to find adjacent ones, okay, assume that all are ones. I mean, choose, go minterm by minterm, go minterm by minterm. Say M0, M0 can be adjacent to this. This is okay. I'm just making a group of 2. Okay, I'm making a group of 2. These are adjacent. Can I make this? These two are adjacent. Can I make this? See here, you take any other combination, it won't be vary with, it won't differ with less than one variable. It will differ in only greater than one variable. It should differ only in one variable. If you are making group of 2, it should differ by only one variable. So I can form, there are 3 possibilities here. Okay, so this cell M0 and M2 are said to be adjacent, although they are not physically adjacent. Okay, they differ only in one bit, so bitwise they are adjacent. Okay, what about this one, M0 and M4? Then this one, the M0 and M1, they are said to be adjacent, and so on. So this is only for 0. What about 1, M1? What are the adjacent one for M1? You tell me. For M1, M0, see these two are adjacent. M1, M3, M1, M5. So now you can see the trend. Okay, it can be horizontal or vertical. Okay, or maybe around the corners, but it should not be diagonal. Okay, I mean you should not remember that, but the logic is it should differ by only one variable. Okay, is this okay? So this is for finding the adjacent number of ones with a group of 2. Okay, now move on to the next page. So before that I should write this: adjacent group of 4. So you need to find the groups of powers of 2, 4, 8, 16 and so on. Okay, so group of 4, let's take 2 variable K map example. Now if it is group of 4, okay, if you are making group or adjacent group of 4, or group of 4 are said to be adjacent, okay, 4 ones, okay, if they differ by, now by what variables it should differ? Now it depends. Okay, it should differ by 2 differ by 2 variables. Okay, now we are forming the groups. Okay, now we are forming the groups. If you are making group of 2, it should differ by 1 variable. If you are making group of 4 ones, it should differ by 2 variables. So what is the possibility of forming a group here? And there is only one possibility, isn't it? So check here, if I am combining all this, okay, these are said to be adjacent if they differ by 2 variables. See, both the variables are changing. Okay, they are differed by 2 variables. Okay, same thing. Okay, take an example of 3 variable. X, Y, Z. Now you tell me the possibilities of, you go min term by min term, form group of 4s. See, this M0 can be combined in what fashion so that it should form a group of 4? Can I combine like this? See, by what variables they differ? See, by what variables they differ? See here, what variables are differing? See, from one column to the another, what variables? This remains constant, Y remains constant, Z is differed, right? That is one variable along the column. Along the row also another variables. That means if you are making a group of 4 variables, it would differ by 2 variables. Okay, if you are making a group of 4 minterms, it would differ by 2 variables. Don't need to remember this. I'm saying telling the definition of group of 4, adjacent one. Okay, this is one possibility. What is the another possibility? So that M0 can be covered in group of 4s. M0, M4, yes, this one. This is another possibility. Okay, which variables are differed? Here you tell me, Y is differed and X is differed. Okay, 2 are differed. So better to say what is not differed. Okay, better to say what remains constant. What remains constant in both of them? Z bar. What remains constant here? Here. See here, X is changing, Y remains the same, Z is changing, so only Y remains the same, Y bar. Is that okay? Is that okay? What is another possibility? Can you see another possible in which M0 can be combined? M0 can be combined. Any other possibility? Or come up with a possibility of group of fours. Come up with a possibility of group of fours. Okay, group of fours means it should differ by only two variables. What are the possibilities? Can't I combine this? Can't I combine this? By how many variables they differ? X they differ, and what they differ with? Y they differ. Z remains constant, isn't it? Z remains constant, X and Y differ. Can we have? Yeah, now you can tell. Yeah, tell me. This one, can we have? Huh? Yes, we can have it. Whole first row can we have? Why? Both Y and Z differs, only X remains constant. Now you are on the track. Now you tell me, this can be combined? Okay, this? Alright. Okay, ये हो गया, और कुछ रहा है? और कुछ बचा है? Okay. So, you got it right? What I am saying? Adjacent group of ones are only if they differ in two variables. Okay. So these are the number of possibilities. So can you tell me the possibilities? Tell quickly. M0, M1, M3, M2, that is one possibility. Then M4, M5, M7, M6, another possibility. What else? M0, M4, M2, M6, another possibility. Tell me quick. M0, M1, M4, M5, another. M1, M3, M5, M7. Next. Last one. M3, 2, M7, M6. Is it okay? Everyone, is it clear? So this is for 3 variables. Tell me for 4 variables. Group of 2 and 4. Okay, so there are various hell lot of possibilities, isn't it? So let me see. I'm just let's take 4 variables. Note down all the possibilities of group of 2s and group of 4s. Okay, for 4 variables, do that. Group of 2s also, do it. I mean, it's going to help you. मैं गधा मजदूरी नहीं करा रहा हूँ, आपको हेल्प होगा. Zero zero. First, tell me the possibilities of group of 2s, adjacent group of 2s. Tell me. Can I combine? No, go minterm by minterm, okay? These are adjacents here. ये ऐसे. Okay. What else? ये ऐसे. ये ऐसे. M0 is adjacent to M1, M0 is adjacent to M4, M2 and M8. Okay, so let me write that. M0 is adjacent to M1, M2, M4 and M8. Is this okay? देखो यहाँ पे it should differ by only one. Sorry, how many variables it should differ in? only one variable. If you are making group of two, देखो m0 and m1, how many variables they are differing in? These three remains constant. A, B, and C remains constant. D is differed. So m0 and m1 are adjacent. m0 and m4 are also adjacent. C, D remains same. A remains same. Okay. B is differed. Right. Similarly, these two are adjacent. m0 and m2. They are differed in only C variable. m0 and m8 is adjacent. Okay. In that fashion, you may find all the possible combinations of twos. A group of twos. Make those possible combinations of twos. What about m1? Now go minterm by minterm. Again, I am saying go minterm by minterm. m1 का कितने ग्रुप्स हो सकते हैं? देखो, m1 is adjacent to m0, then m3, then m5. What else? m9. See here, m1 and m9 are also adjacent. I'm seeing some blanks. Please ask if you are not able to understand it. Okay. Definition of adjacent of group of twos is it should differ by only one variable. Okay. Definition of group of four adjacent ones is should differ by two variables. I mean, take to the power of that. Now, same four variables. This group of and so on. Okay. This group of whose class is there after this? Huh? Dubey sir. Who? Huh? So can I continue? Good. No faculty means off. No faculty. Huh? New faculty. Achha, new faculty. I'm sorry. So he'll be coming there. Okay, all right. So take I'll label this again. M8 now you make group of four variables. Okay, four not group of four variables, four minterms. I'm sorry, make a group of four minterms. Okay, group of four ones such that they should be adjacent. Okay, you tell me about m0. Tell me first, concentrate here. यहाँ पे देखो m0 minterm. Go minterm by minterm. Again I am saying go minterm by minterm. m0 को consider करो. m0 make a group of four. Okay, can I make a group of this one? Do they differ in only two variables? See here, they differ in D, they differ in B. Okay, what remains constant is A bar and C bar. Okay, another possibility, you tell me. Yes, m0, m1, m8, m9. This is another possibility. Okay, see, only the variable which are constant are C bar and, you tell me, B bar. Okay, you take corresponding rows and corresponding columns. You tell me about the other possibility. m0, m4, m2, m6. Yes, m0, m4, m2, m6. See here, what are the variables which are constant? You tell me. D bar and A bar. A bar, D bar. What about this one, the red wala? What are the variables constant? C bar and B bar, right? What about the yellow one? What are the constant? C bar and A bar. So I'll write A bar, C bar. Any other possibility? First row. Okay, you can have this. Okay, tell me the expression. They differ only two variables. The expression turns out to be A bar and B bar. Any else? Anything else? There is one more possibility. Take the corners. M0, M2, M8, M. What is that? 10. It's 10. Tell me the variables which are common. So B bar and D bar. Is this understood? यहाँ पे एक भी बंदा है जिसको ये समझ में नहीं आ रहा है? Tell me. While grouping, making group of, now let me write that. Okay, nicely. Group of. Oh. Now this is only for one minterm M0 I have considered. Okay, you take any minterm and come up with different possibilities of adjacent fours. Okay, group of fours. You tell me about M0. Tell me groups. M0, M0, M1, M3 and M2. Another possibility is this M0, M2, M8, M10. Third, M0145. Okay, and here, what else? 0189. Anything else? That's all. 0426. Huh? 04 12 and yes, there is one more possibility. This one. M0 4 M12 M8. Anything else? This is only for this corner one. So for each one of them, it would have 6 different possibilities. You try it out. Okay, you take any minterm. Check the number of possibilities of various fours it can group into, adjacent group of fours. Which one? Okay, what I'm saying is, and we are making group of to the powers of 2's. Okay, we have seen how to make a group of 2's. We have seen how to make a group of 4's. Here, if we need to make a group of 2 minterms, we should make sure that it should differ with only one variable. Here we are considering a group of 2's. That means it should differ by 2 variables. Okay. If we consider minterm this, okay, it is adjacent to which variable such that it should differ by only 2 variables. M0 is adjacent to these 4 minterms. This is one possibility. Which are the variables which remains constant or which differs? Okay, which remains constant? This A bar remains constant, C bar remains constant. B is changing from 0 to 1. B is changing from 0 to 1. But C remains constant, C bar remains constant, and A bar remains constant. So it differs with 2 variables. So this group are adjacent number of 4's. Take this 4. Okay, 4 corners. They differ by only A. B bar remains constant. Okay, you consider corresponding rows and corresponding columns which we are marking. Take these 2. It is differed by only C, but B bar remains constant. Okay, So two variables are different, two remains constant. Okay. So those again forms a group of four adjacent ones. In such a fashion, you may find six different possibilities of M0 which can be combined in a group of four adjacent min terms. Is that okay? Anyone here? समझ रहे हैं? नहीं समझ? ठीक है? Is that okay? Now, with a group of two, there are a hell lot of possibilities. We can combine this, there. Both possible. Huh? 64. Okay, in total. Okay. I thought for one. Okay. For yeah. When 16 fours are for each, it will be there will be four. So 16 fours are. Huh? हाँ हो सकता है हाँ हो सकता है ना मतलब वो रिपीट होना ही है मतलब फॉर एग्जांपल इफ m0 and m1 if I consider m0 and m1 are adjacent when I go for m1 m0 and m1 are again adjacent I mean you go for unique one okay I'm just selling for each I'm just considering one min term at a time okay adjacent repeat bhi kiya to it doesn't matter whenever you are repeating the terms x plus x is nothing but x only. Okay, if there are repeated number of variables, we simply cancel it then. Okay, we don't consider it. Just x plus x is nothing but even if you take twice, it doesn't matter, right? So even if it repeats, don't worry. All right. Go for group of 8. Group of 8. Go for group of 8. Go for group of 8. अभी 8 के लिए उतने squares तो चाहिए ना मतलब कम से कम the map should be of 3 variables. Okay, I mean for 2 variables we may not get a group of 8, right? Form a group of 8 for at least 3 variable K map. Make a group of 8. Tell me for group of 8 how many variables it should differ in? All 3 variables, right? Take 2 powers, no? Take 2 powers. Let's say x, y, z. 0 0 0 1 1 1 1 0 and 0 1 2 3 4 5 6 7. Tell me group of 8. Only one possibility. Make a group of 8 variables for 16 for 4 variable group of 8 min terms for 4 variable K map. Do that. Tell me the possibilities. Homework for you is to form a table for each and every min term. Okay. Homework for you is to form a table for each and every min terms. Check out how many possibilities are there for each and every min term here. Oh, sorry. Oh, I have repeated this. Okay, you make 4 possibilities here. 4, 5. Tell me, group of 8, consider me, go min term by min term, go min term by min term. 8 possibilities below. Can I group this? Check the number of variables they differ in. They should differ in 3 variables. So group of 8 adjacent ones, right? 8 adjacent ones differ in 3 variables, right? That means you should get only one variable here. Which are the variable which is constant? A bar. Tell me the others. Can I combine this one? Yeah. Another one. Bolo. Yes. Yeah. 8. Is that okay? Another possibility. Huh? This one. That. Anything else? Huh? I'm just considering M0 here right now. For 8, tell me. That's it. That's it. Okay. You take any other min term. Okay. Find all the possibilities of this group. So tell me the groups first. So M0. Tell me the group of 8. M0. If I am taking. See. Okay. You can write it. Okay. M0 1 2 3 4. This group. That group. Four different groups. You tell me the variables for this. What is the variable for this? Which remains constant? B bar. For the green one, tell me, for the green one, what remains constant? Yes. What about this white one? Ye wala, X. Huh? D bar. Is that okay? Anyone is facing any difficulty here for finding adjacent ones? Okay. Alright. Can you please check if he is going to come, or shall I continue? No faculty. You said new faculty, right? Will be there. Right now it's no faculty. Okay. So I am going to continue. Equivalent. Okay. Fine. So it's not a SOP or POS form. They are not equivalent. Fine. So this no adjacent one. So okay, fine. Now let's take an example. Now I'll tell you the strategy. First, take an example. Take an example of this one. F of only two variables x, y. Take simple example 1, 2, 3. Draw the K-map. Draw the K-map for this. How many variables are there? As a first example, I will tell you. Draw the K-map. By the way, हम कर क्या रहे हैं? What is the aim? Don't forget the aim. The aim is to minimize the Boolean expression using map method. The one method we have already seen, using axioms of Boolean algebra. we found that that method may be tedious, may not be easy as the variable grows. That's why we have gone for the K-map method, Karnaugh math method. It all starts with forming the number of squares equal to 2 to the power number of variables. Okay, so there will be 4 squares here. X, Y, 0, 1, 0, 1. There is only 1, 2 and 3, it's marked. Okay, 1, 2 and 3. Where is 1, 2 and 3? Is that okay? That's the first step. Now all of you keep your pen down, just listen. The next step, very important step, is first step to form the K-map. Next step is to find the ones which are alone, isolated ones. You find the ones which cannot be combined with any other ones. Okay, you find ones which cannot be combined with any other groups. Okay, which can't be combined with group of 2s, which can't be combined with group of 4s, which can't be combined with group of 8, and so on. Okay, you find isolated ones. Okay, if it is not present, go on to the next step. In the next step, you find group of 2 adjacent ones. Okay, make a group of 2. Okay, adjacent group of ones. Okay, you make a group of 2 ones. Make a group of 2 ones. Okay, so in only such that it is the only way of grouping that variables. Okay, so I'll come step by step. Okay, first see there. Okay, is there any kind of isolated one here? Go min term by min term. Go min term by min term. Check this first. जहाँ पे 1 है वो पहले check करो. See this one. Okay, consider this 1. Okay, is it an isolated one? Can it be combined with other ones? Yes, there is one possibility. We can combine like this. We can. This one at least one possibility is there. Okay, so it's not an isolated one. Is this an isolated one? Is this an isolated one? No. Go to step. Step 2 is make a group of 2's such that it should be only one way possible. Okay, say for example this is the min term, okay, 1. Make a group of 2 such that that should be the only way possible to make a group of 2's. Say for example I am taking one min term 1, okay. Is there only one possibility so that this min term can be covered? There is only one possibility. Which is that possibility? This one. Leave it. Okay, write that. What is that? Tell me the minimized expression. So here, this x varies, y remains constant. That becomes y. Okay. Check for the leftover ones. Check for the leftover ones. This is the leftover ones. Okay. Okay. So now, if there are some leftovers left, okay, leftovers if they are left, try to combine in bigger number of groups as big as possible. Okay, try to combine them in bigger number of groups as big as possible. Groups may be in the powers of 2, 4, powers of 2. Okay, 2, 4, 8, 16, and so on. Can it be combined like this? Okay, that's the only way. Okay, form if there are leftover ones. Okay. You need to group it in as big as possible. I may group alone, okay, but no, that may not give a minimized expression. I need to combine in such a way that it should form a bigger group as possible. Okay. So I'll combine like this. Tell me the expression for this. Okay. That's your minimized expression. So f, it becomes x, or what is the cost here? 4. 3, right? I mean 1 gate and two inputs, right? 2 input OR gate. So the cost is 3, right? If we are calculating min terms here, what is 1 x? What is 2 here? What is 3 here? How much is the cost? 3. How many is the inputs required? 6 inputs. How many gates are required? 3 AND gates, 2 OR gates. What is the cost? How much? 11. What is the cost here? So that is a reduced expression. Don't need to go for any Boolean algebra. You will get directly the minimized expression. Okay. Here. Check total number of inputs. How many total number of inputs are required? ठीक है, देखो बच्चों, और गेट ऐसे, एंड गेट ऐसा लगेगा, और एक एंड गेट लगेगा, ऐसे 3 एंड गेट्स लगेंगे. और इन सबको कंबाइन करने के लिए एक और गेट लगेगा. सो इट शुड बी 1 हियर, राइट? नो सॉरी, क्या ओनली 3 इनपुट? ओके, 3 इनपुट, ठीक है, 3 इनपुट और गेट, ठीक है. कितना हुआ कॉस्ट? आई मीन 9 इनपुट्स, राइट? 9 inputs. 9 inputs. How many gates? 4 gates. Sorry, it's 13. Cost is 13. So anyway, it's reduced by 10. So cost here is on this. I've taken this as 2, so that's why. So it's a 9 input, total input and total gates. Okay, that becomes the cost. That is 13 here. That's reduced to 3. Okay. So this is for 2 variables. Now is it clear? Take this one, 3 variable. Example, f x y z 3 4 6 7. Okay, just concentrate first. Just concentrate here, and then you can continue. Okay. X y z. Tell me where it is. 1 0 1 2 3 4 5 6 7. Is that okay? Find the isolated ones. Is there any isolated one here? No isolated one. Okay. Form a group of go min term by min term, form a group such that, okay, that is the only group in which that min term can be combined. Okay, mark my words, each and every word of is important, okay, of my statement. What I'm saying is, if you won't find isolated ones, okay, go increase your group, okay, make a group of 2 such that that should be the only group in which the min term should be covered. Okay, take this min term, okay, this one, okay, what is that min term? 3, okay, it 0 1 2 3 4, oh yeah, sorry, yeah, there is one, yeah, is this an isolated one? No, there is this possibility, वो अकेला नहीं है, उसका साथ है, कोई साथी है उसका, तो ये आइसोलेटेड नहीं है. ओके, नाउ चेक, इंक्रीज द ग्रुप नंबर्स. ओके, इंक्रीज द ग्रुप नंबर टू 2. द ग्रुप शुड बी फॉर ईच min term. First make encircle those groups in which, okay, the min term can be covered in only one way. In only one way, okay, remember, only in one way. Is that only one way in which this min term can be covered? This min term, okay. What is left? This one, okay. Combine this. So can you tell me this expression for this? X Z bar. What about this? X Y. That is the expression. X. Is it okay? X Y Z or X? Is it okay? Huh? Not X here. X is changing, right? Is that okay? Yeah, tell me if you are having doubt. Huh? Which one? This one. This one, you want to say that this should be combined? Okay, fine. Let's go step by step. I have written directly, no? Fine. Alright. Go min term by min term. This way. How many possibilities are there? Either I can be combined with this, which is already combined, or I can combine with this. Is there only one way? This one. Either I can combine with this or I can combine like that. 2 ways. Is that only one way? No, there are 2 ways. How many ways are there? See, it's not necessary to follow my procedure if you are comfortable with other procedures. Okay, the expressions, the minimized expression may be in different form, but it should give the same cost. If that is so, I'll give the marks, otherwise 0. Okay. What I'm saying is, any way you follow, okay, the cost. See, you may not get unique expression. You may not get unique expression, but of course the cost should be as minimum as possible. Let me stop.